Hello and welcome to another tutorial. So this time we're going to be continuing with the series on making sim-style AI. So last time what we got set up was so we had smart objects that could advertise the kinds of things that they were able to do, and the AI was picking entirely randomly from those. So what we want to change now is we want to make it so that the AI has some actual needs that they are trying to satisfy and have it that different interactions are going to affect those. So that's our focus of what we're going to get up and running. So to start with, we need to think about what do we want to have need-wise. And this is actually a really important decision in terms of how we actually frame these things for it being sort of easy for us working with. And so the setup in The Sims is a really reliable, proven one. They've shown it works quite well. And so going to lift off of that. So having the concept of them having a fun stat. So that will track sort of how much fun they're having. And, we could use things like hunger and thirst, but I think that's something where using that sort of combined stat of energy is probably a better one. And I mean, it makes a lot of sense. It works well in The Sims for having that. So we're going to need to set up for those stats, and we want to be able to have that those can change over time and different interactions will do different things there. So what I'm going to do, we've got currently our simple AI. I am going to set up a script that is now going to be not so simple AI, because we're starting to expand what this is going to be able to do. So we're going to bring this script over, and we'll sort of lift a bunch of stuff from the simple AI one, but we're going to turn that one off, and we're going to set up this new one. So initially we'll just transfer everything over, but then we'll start making those changes to it so it's got those different capabilities and different sort of stats. So I'm going to take everything that there was here in simple AI, and I am going to bring that over. And then what I'm going to do is we're going to work on improving this not so simple AI. So the reason I'm keeping both of them around is just because it gives us a good point of comparison there. So there we go. And I'm going to close everything else for now. So, okay, we've got that. We'll have that script on there. Now the AI, it does have this feedback UI. That feedback UI, I'm actually going to make some modifications to that. So what I'm going to do is I'm going to update the prefab here, and then I'm going to edit that prefab, because I want to change this so that our feedback here, I'm going to get rid of that text, and instead I'm going to add in two ones that what it's going to be is these are going to be our stats. I'm going to put in a stat panel. So that currently takes up the whole space, which is fine. I will change that so it's a darker background. I think will work better. And that is just going to have in it, I'm going to put a slider. Well, I'll put two things. What I'll do is I'll put two images in it, and one will indicate the type of the particular stat, and the other will indicate the actual status for it. So I might actually make that text, might work better. So I'll put in a little bit of text. So this text will be, for example, energy, and I'm going to position that text anchored over on the left. So we'll just make it that it's oriented a little bit like that, and we'll give it a tiny bit of a spacing there, increase the size of that a bunch as well. That's pretty good. And then the image, I'm going to make the image a sort of similar setup. So I'm going to say that it is anchored again on the left. I'm going to set its X position to 0 for the pivot. And we'll set based upon where that label is. So we'll set this to be at 200. And its width, well, what I might actually do is set it to fill up the full length. Because what I want to be able to ideally do is have this as something where I can really easily just scale this. So potentially something like of that, and then the right value, if I increase that, that could work. That's maybe not a great way of visualizing it, so I think going for a slider will be a little bit better here. So we'll put a slider in, we'll set it up like this, 200, 5, 5, and 5. We get rid of the handle, so we turn that off, and then that way the fill area fills up nicely. We do just need to usually with that fill area update those values there a little bit just so it actually works a bit better. We update the background color here so that we can see it a bit more clearly. And then now we have something where that bar is going to change quite nicely. So that looks good. We've got our label. We've got our indicator bar that we can control. And the label, we just want to make sure we're positioning stuff right. So that's going to be one of the stats. Then we're going to have a second one, and we just use our usual vertical layout group. And we're not going to force expand in height, but we will let it control the child's width and height, set a little bit of spacing and padding there on all of these. So can have it, actually force expand height is going to work okay for that. So this is going to be stat energy. And then we'll also have our stat for fun. So this will just make it easy for us being able to see the status of this for the character. So that looks pretty good. We'll be able to keep an eye on that. So we can save that. So, okay, that's the basics of having that. Let's actually get some stuff in for these stats. So, okay, we're going to want to have our initial fun level. So I might start that at 0.5. We're going to want to have our initial energy level. So then these, without anything else happening, we want these to be able to decay over time. So we need a decay rate there for them. So what I would have is base fun decay rate. So if we think, if they're at that default, how long do we want it to take for them to be at the lowest possible value? So that's something where I think if we set that to 0.01, that would be about 50 seconds. That's maybe a little bit quick, so maybe we want to go a little bit slower again than that. So I might make that 0.005. And I think I'll do the same for the energy level as well. So we'll have these nicely grouped, energy. We'll have base energy decay rate. So that's good. So we'll be able to update those. So then we need things like our current fun and current energy levels. So we'll have current fun and our current energy. And what I'll do is I will make both of these public, but do our usual setup where these are publicly gettable, but the set is protected. And we don't need to give an initial value because we're actually going to set that in awake. So then in awake, first thing we're going to do is current fun is initial fun level, and current energy is initial energy level. I'll set up so that we have our UI slider, so fun display, and we'll have our energy display as well. So we'll also update these at the same time. So fun display, value, and our energy display value. So that's good. So we've got those values there. That will get properly populated in. Now, the other thing that we want to then do is have these updating. So in our update, what we would do is, okay, well, current fun minus equals, and we would use our base fun decay rate by time.delta time. But we need to cap that so it stays between 0 and 1. So I actually do this as a mathf clamp 0, 1, current fun minus that. And I would then update the display. And then I also want to do the exact same thing with the energy. So current energy, and the autocomplete is helping us out there. We just want to double check that that looks correct. So that's good. We should have now fun and energy values decrease for this character over time. And it should take it about 100 seconds. So a little bit over a minute and a half to get to the point where that is fully depleted. So that's pretty decent. We'll link up our different sliders here. So our energy display and our fun one. So then if we watch this, we should see, and the easiest is probably going to be to look at these, and we can see those values are decreasing, which is great. That's what we wanted to have happen. So now we wanted that the interactions that are happening affect those stats. So if we take a look at how these interactions work, so we've got a bunch of different smart objects here. So we'll go and take a look at our base sort of smart object, because that's where we've got a lot of things configured in terms of the interactions. So, okay, we have our base interactions that happen here, and we have the stuff in terms of registering, all of that. If we go and let's take a look at our interactions. So this is an important thing. We take a look at this, we can see, okay, it's got perform, it's telling it who's performing it, and there is something for on completed, so that looks pretty good. And let's take a look at what some of those actual sort of actions in that look like. So we've got a couple of interactions here. So we've got a very simple interaction. So that has tracking if it can be performed. The perform logic is happening here. It's keeping track of if it's instantaneous or if it's over time. If it's over time, there's further things happening there. So there's stuff there for ticking that. So there's a lot of the bits there that it looks like of what we need, which is great. So, okay, when it's performing the action, that's where we want to be able to say how that stat changes and what the stat change is. So I think all of our interactions need to be able to say, well, for this interaction, here's the actual stat change. So I'm going to say this because we might have the one interaction can modify multiple stats. So we'll say system serializable, have a public class interaction stat change, Now we need to say what stat it actually changes. So public enum e target stat, or I might just call that stat. So we can have energy, we can have fun, and I'm actually going to put this into the not so simple AI because it kind of makes sense that it owns it. It's kind of one of those things where it does then, we are creating a dependency between the two, but that's something that there's times to maintain the modularity there, and there's times where maintaining modularity gets in the road. In this case, I think the stats live on the AI. It makes the most sense for the AI to know that stat type, and although that means there is a dependency there now between these interactions and that AI, I think that's okay because we kind of need that as it starts to have more two-way communications happening there anyway. The two have to become more linked. So we're going to have with this our target stat. Then we want to be able to say what the change is. So there's two different ways that we could approach this because we have some interactions that are instantaneous and we have some that happen over time. So this value is actually going to get interpreted slightly differently depending upon the interaction. So, okay, we're going to have the amount of change. So we'll have a value. So then here we would have protected list of interaction stat changes. And actually, this doesn't need to be a list. It can just be interaction stat change. Stat changes. And now we can actually start to configure these for our different objects. So we have things like, the toggling power, changing channel. So those, pretty straightforward. Those actually don't need to cause a stat change. Those cause a change in the object. But things like of our bookshelves, they have browse. So while it's browsing, well, let's say that browsing through the books, that's going to impact on fun. And over that duration of browsing the books, let's say it changes fun, it adds 0.2 to it. So that might be the left bookshelf, and we'll do the same for the right bookshelf. I'd actually make it that that's a slightly lower amount. Maybe it's less interesting books. So, okay, we've got those happening. TV, well, we need to have an interaction here that actually is going to have an impact because toggling power, things like of that, doesn't really actually do much. We need something where it's a sort of watching of the TV. So I'm going to create another script here. TV interaction watch. So this one is going to be a little bit similar to our change channel. So it's going to require that it has to be attached onto a TV. That makes sense. And I'm going to bring over all of these ones. So it gets that. So it can perform it if, and then we can update this so it uses the same simple interaction. So it can perform it if the TV is on. So watching requires the TV to be on. So then if we go to the TV, so because things like changing the channel and that are instantaneous, watching the TV, however, well, that's going to be watch TV. The interaction type is going to be over time. We'll say that they watch for maybe 5 seconds. And again, stat change wise, that is going to add some fun. And it's going to add 0.25. So we've got 3 things that add fun. We have nothing that adds energy currently. So we need to add that in. So if we look with these, we have these interaction markers for stuff. I'm going to set up a similar thing for our little microwave setup here. So we have the table that has the microwave and toolbox on it. Just going to put those under that. And then the microwave, I'm going to give it a smart object similar to what we've got for the TV. It'll just be able to be a fairly generic smart object though. We don't need anything too specific with it. But I do just want a way for them to be able to have something that will give them food and give them energy. So we have the microwave there. Now interaction markers are all at about the same point. So the microwave one will create an empty object under that. That's our interaction marker. And we'll move that out. About 1.25 is probably about right. That should be, main thing I want to make sure of, it has to be within the nav mesh. So that's a little bit outside of it. So I'm going to bring that more to 1.5 so it's a point that it can actually reach. So, okay, we've got our microwave, we've got the interaction marker. Let's give it a interaction. This can just be a simple one. So we'll call this heat food. We'll say it's an overtime, takes 5 seconds as well. This, it'll update the energy by 0.25. And we could be using negative values in here as well. So you could have stuff that, because we can chain in multiple different ones, there's multiple ones that could be happening here. So, okay, we've got stuff that can have an effect. We don't have it causing that effect yet, but we do have it that it is able to kick off and do those things. And all of our interaction stuff goes through a very consistent sort of setup. Everything is based off of simple interactions at the moment. So we can take a look at what we do with the simple interactions. So if it's an instantaneous one, we can see here it goes through and it will come into this perform. So perform at the moment takes a mono behavior. So that's likely going to need to change because that needs to take something where it can actually modify those stats. So we can see we've got onCompleted. So at this point, it should definitely update stats. So this is a case where we would check if the interaction that we are performing, which we can see, we have those as stat changes. So if a stat changes, and we actually have ones of that, so if stat changes length is greater than 0, then we need to apply stat changes to the performer. And the amount that we apply of this is we would apply 100% of it. And the reason I'm doing it that way is because down here in update, so down in update, we're handling where we are performing an interaction over time. So I can't just apply 100% of the time here, because if I did that, that's going to be applying at every single update. So I need to work out the proportion to apply. So that means I need to work out how much elapsed time has changed by. So I need to keep track of the previous elapsed time. So I grab that, and then what I update this by is the performer elapsed time minus the previous, but I need to convert that to a percentage, so divide that by the duration. Now the catch with that is this, say we're at like 1.9 seconds and the delta time was 0.2. We'd go to 2.1, which means we might have overshot the duration, so we would add too much of a stat here, or take away too much of a stat, which we don't want. So that means I need to clamp this elapsed time here. So what I would do is actually I would say elapsed time is the mathf min of performer elapsed time plus time delta time and the duration. So that will prevent it from going over the duration value. So now I've got these two functions, apply stat changes, and this is something I'm going to actually set this up here. So I'm going to have public void apply stat changes. Now at the moment it just has the motto behavior, and we have then the proportion, so the amount to actually apply. So what I would do is, well, I loop through the stat change, then that stat change dot value, so its value multiplied by proportion, that corresponds to the specific thing that I need to change. So update individual stat, we would be able to say the particular stat and the amount. So now that we've got this at this point, we have to make a call on how we get this information to the AI. And this is something where there's different ways that we can approach this. We could be using sort of more indirect methods of sending messages or using events. We could also have tightly coupled, it links to a specific class. And it's not an easy, clear-cut decision in most cases. There's advantages and disadvantages to each side. So it's not a simple choice often. My feeling in this case is that the best option is going to be setting up for our systems here with our different AIs, having a base class that gets used and that we can pass that through. So I am going to set up a script here, and I'm going to call this common AI base. And that is the one that I will actually put the stats onto. So what I am going to do is, if we take our not so simple AI, I'm going to take all of this stuff, bring this over to here, and I'm going to remove the stats from here. And I'm going to also move things like these stats over. And I'm going to make it that a bunch of these things also move over. So this will inherit off of common AI base. There's going to be other things here like our interactions. These can actually move over to the base class, so quite a bit of stuff will get moved over. The stuff that will actually remain is going to be that picking logic. So that moves over, a lot of these things, so quite a few bits are going to transfer over. So the easiest way is actually going to be if I do this. Bring these over to here. Random interaction, that will not carry over. Interaction finished will. So that becomes a protected virtual void. Update becomes protected virtual void. We get rid of that side of things because we're not doing any picking of interactions. Then our not so simple AI, well, doesn't really need that. Doesn't need anything in awake. We will change the awake here to protected virtual. So all of these ones, I'm going to make them protected virtual just so that if we need to, we can override them. So this will be protected override. Do a base update. Do the same with start. And all of these bits disappear. So interaction finish we don't need, and this one we don't need either. So it gives us something that's got a common base there that we can be working from. And we'll do the same thing with the simple AI script. That will inherit off of common AI base. That will retain all of those. Doesn't need a wait or start. Does have this. So it will do the base update. Now this needs to change a little bit. So if the current interaction is null, then this will pick one like that. Still has pick random interaction, but all of the rest goes away. So cleans up things a little bit. And so common AI base is now what we are going to pass through. So we go to our base interaction, and everywhere here where we were doing this, I'm going to comment this out for now, just because I want to make sure this is going to highlight all of the areas of code. So this is following the approach I tend to recommend of when you need to make a large change like this, intentionally break the code. Because that way you find all of the particular things by actually the errors that flag up. Makes it really easy to track stuff down. So that looks fine. So this is grabbing out so this we need to still be keeping track of our particular performers. So that's something where when we add something into the performers, we are going to need to keep track of the actual performing AI. So that's easy enough to do. We can populate that in here. We've already got other stuff we're feeding through. So we would just have performing AI is the performer. Because then here, we can do performer, performing AI. Check, and we just feed through, fix up any errors that come up. That's all of them resolved. So then our base interaction, well, we want this to be able to go, hey, performer, update this stat. So then in our actual AI here, we are going to set up a function that what it will do is we'll have a public void, we'll have a stat target, the amount to change by, and then this is where we can just use, okay, well, switching based upon that, and we can check and see, okay, is it energy? Yep, if it's energy, then current energy plus equals amount, break, and then we can have same thing for fun, current fun plus equals amount, break. That should mean when it performs those interactions, it will actually go and update those particular stats. Now, the simple AI, also by virtue of this, gets those stats now. The not so simple AI doesn't do anything extra now, so it's actually a little bit less capable. But what I'm going to do is we'll do this, because what I want to see is it actually applying those stat changes. And I'll put in a little helper here. So debug log, update, target by amount. just so we can see that it's actually changing those stats. That's what we want to hopefully see, that it goes and performs an interaction, and we see a message saying that a stat has actually changed. Now, we need to turn on Simple AI. Now, we do have a couple of things getting grumpy at us, which is okay. So that's because we need to link these up for the Simple AI. So we link up our energy and we link up our fun. So let's run these. So it's going to heat food at the microwave. So we can see it's updating energy and it's updating it by positive amounts. And we can see the energy bar went up. So this is great. So it can perform things, it'll have an effect. Now is the key part. Making it pick what it wants to do based upon what things are available. So if we take a look at what the Simple AI used to do, it used to pick a random interaction. So we're going to steal a bunch of stuff here from this and bring this over to the not so simple AI. So we still want it to have some of this logic. So that time until picking another interaction, that's actually something I think that's reasonable for us to bring over as well. So I will bring over that also. So not so simple AI can have that variable too, but pick best interaction is going to be what it's doing. So what the simple AI did is it just picked a random one. So it will grab this so we can see what it does. So it goes through the registered objects, picks a particular one. So we're going to change that. What it needs to do is it needs to go through every object. It needs to check the interactions, and then it needs to score them. So we're going to loop through all the objects. So for each smart object in all of the registered ones. Then we loop through all the interactions. So we go, okay, well, for each var interactions in a smart object, and we need to find the interactions for that. So that's good. Now we need to check, okay, can that actually be performed? Because if it can't be performed, we just ignore it. So if that interaction can perform, so if that is false, we skip it. Otherwise, we need to score that interaction. So score equals score interaction, and we need to score it for us. So we need to say, okay, we'll score this interaction. So how that works, and I might actually set this up here. So we have score interaction. So that's going to be our base interaction. So it comes down to if that's got stat changes. If it doesn't have stat changes, that actually makes it trickier. So we'll check first. Okay, well, if interaction, and so we need to be able to access those stat changes. So that's something where if we go to our base interaction, these are currently set as being public like that, sorry, protected. So what I'm going to do is I'm going to change the name there. And I do need to mark this as previously serialized as, just because I've already got data there. So Unity Engine. It's the handy thing if you do need to rename things. What you can do is do formally serialized as and the old name. That way that will work, because that lets me have here a interaction stat change, stat changes, and link up to that. So easy thing, if you do mess up the name and you've already set up some data, you can go and do this. That's going to then transfer stuff over, and then after you've made sure everything's resaved, you can actually go and remove the formerly serialized as. So if stat changes, length is equal to 0, then we need to work out a score for it. So we'll come back to that one. What we'll probably do in that case is something like we'll have a detected float default interaction score. So this will be the by default the score for a particular thing. So it might make that actually just 0 because it doesn't necessarily have a huge benefit for it happening, but we might find we need to tweak that. So now we want to go through. So score is equal to 0. We'll return the score. We go through each of those changes, and then we need to score that particular change. So, okay, score plus equals, I'm going to score the change, and so it will be change and the target and the value. So I'm intentionally doing this fairly sort of split up. The reason for that is this is stuff that I likely may want to customize and change quite a bit. So having this be fairly sort of split up into smaller functions makes it very easy for me to modify individual pieces of this if I need to at a later point. So then score change estat target and float amount. So now this is where it gets interesting. So first I want to get the current value. So float current value. So I'm going to steal from the Common AI base this. So I'm going to grab that, just because it saves me having to write out the switch statement again. So in this case, current value is equal to that. And in this case, current value is equal to that. So part of the reason for structuring the stats the way that I did was so that I could easily work with them in a fairly consistent manner. So, okay, I know what the current value of the stat is. I know higher is better, lower is worse. So if it's going to decrease it, that's bad. If it's going to increase it, that's good. How important that is should be determined based upon where my stats currently are. Like if I'm at really high energy, something that boosts energy shouldn't count for as much as something that, if I was at really low energy. So we need there to be a bit of an impact from that. So if I'm at low energy, an increase is more important. So I could have something where, okay, well, 1f minus the current value times by amount. What if we use that as the score? Let's sort of think about this. And this is something that you would do a lot of iteration on. You might run through curves. You might have different curves for different stats. But let's think about this. If I am, let's say the amount's positive. So the amount is going to result in an increase. If I'm at a really high value, my current value is going to be near 1, which means this is going to get scaled down. The benefit of it decreases. If I'm at a really low value, it's going to have pretty much that full amount. So it's going to be more beneficial. If that amount was negative, then again, when I'm at a really high value, has less of an impact. When I'm at a really low value, it has more of an impact. So that seems okay for the score change. So it should mean that the more positive, the higher the score value, the better something is to perform. And this is actually what some versions of The Sims do. They get all the interactions, they score them based upon what the impact is going to be, and then they pick randomly from those, which is exactly what we are going to be doing here. So what I'm going to set up is just a little class. So scored interaction, that is going to have a smart object, target object. It's going to have a interaction, and it's going to have a score. And what I will have here is a list of scored interactions. So I add this into here. So what I would do is I would say, okay, well, scored interactions, add new scored interaction, and I need to give it the particular values. So it's pretty much got a lot of the ones correctly there for me. I want to make sure I pass through the object as well. So the target object is the smart object. Make sure that's linked in. So it's good. We've got a set now of these scored interactions. Well, if we ended up with none of them, then we exit. There's nothing to do because we can't pick something where we've got nothing there possible to pick. Now, otherwise, I need to sort these. Quickest and easiest way to sort these is going to be using link. We could do the sorting ourselves. We could set up custom sort operators. I generally prefer using link. It makes my life a lot easier. What I would do then, because I can say scored interactions, order by, and I want it to be, by default, it will be ascending. So, okay, order by, well, have my scored interaction. I get scored interaction dot score. So I want to go via that. Can do via toList. Now we could, as I said, we could set up a function for doing the scoring as well. I like using link for doing stuff like this, just because the syntax is a little quicker and cleaner to write. So this, I might actually rename this to unsorted interactions. And then this, we have sorted interactions equals that. So we've got that all sorted in there. Close that. Now I can pick randomly, because what it should be is if I pick the best one, that should actually be the one that's going to give the most benefit. So what I would do is usually have a control for how many I can pick from. So interaction pick list or pick size. So we might want to pick from the top 5 interactions. So int max index is going to be the mathf min of interaction pick size and sorted interactions.count, because we want to make sure we don't pick something that's an invalid one. And then we would say selected object or selected index. Selected index is going to be a random range from 0 to max index, and then we can actually grab out these particular ones here because we know the selected object. So the selected object is going to be sorted interactions at that index and the target object. We know the selected interaction can come from that same thing as well. And then we just need this logic here. So that's part of the reason why I kept this stuff around, was so that because I know this is already working for performing the logic. So this should mean that we pick a random best interaction. So sort and pick from one of the best interactions. Now we're going to verify this because we've made a bunch of changes here. We don't want to just assume that this is going to work. We do want to make sure we properly test and check this out. So I've set a breakpoint here. We're going to attach. And then we're going to run this. And there's a couple of key things I'm looking for. One is that it's actually generating a sorted set of those interactions. So we can see the unsorted ones, it's got 4 ones. So using the microwave, got a score of 0.125. TV had a score of 0. Reading a book, got a score of 0.1. And from the other bookshelf, 0.07. So that looks good. So we'd expect the microwave to be the top one because that had the highest benefit. So when it's sorted, so that you can see it's gone and sorted it in ascending order. So this was where me not really thinking that actually was supposed to be order by descending. I pretty much always guarantee I get ascending and descending mixed around. After a very long time of doing this, still ends up being a thing. So, okay, it's going to sort them now. So this time the sorted set microwave is the highest. So max index is 4. So can only pick one of those, but it's going to randomly pick now between those things. So we have the case here where what thing it does is going to be based upon its current state. So it's going to grab a bunch of things out. Now we've only got 4 interactions here. If we had a lot more, it's going to mean that it tends to focus on things that are of most benefit to it. And we could also, with this, I'm going to make it that, firstly I'll turn off that debug because that debug is a little bit spammy now and we know that it works. So what I'm going to do is make it that maybe we have stuff that has a lot of fun component to it, but it might actually have a downside. So it might be something where it's a case of, okay, it's, I think the TV is a good one for this. We have the watch interaction. Let's copy and let's paste that component as new. And let's say we have something where it's a case of, all right, this is an exercise program. So that is going to be fun, but that is also going to have an impact on energy. So what this will mean is we can then, when it goes and scores stuff, we should see that it might make it that it, when we run it, we'll be able to see it's going to be something that it will have fun, but it is going to result in it losing a lot of energy. So its fun's gone up, it's finished browsing, they'll then go and pick something again. So now we can see with the sorted interactions, it's got using the microwave, it's got the bookshelves, it's got the toggling power to the TV because the TV is off at the moment. So there could be ones where we have a bit of a chain of dependency there. So now the TV is on. So we'll see there will be a different set of interactions. And we can see there's a lot more interactions available now. And so microwave is still pretty popular. The watching the TV, and this one gets a pretty decent score, but we can see bookshelf, other ones where different scores there, turning the TV off. This one has quite a negative score, and that's because this will be the one where stat change wise, it's going to be increasing the fun, but decreasing the energy. So when we score that for the character, because if we take a look at their current energy and their current fun level, their fun level is high and their energy is a bit low. So that means something that adds fun is not going to be super popular, and something that takes away energy is also going to have a larger impact. So what we would find in that case is it's generally not going to pick something like watching the exercise program. So it's going to watch TV because that added to its fun. And it ended up turning the TV off because that was something where it chose to do that because it's random what it can pick between. So what we said is that range of things that it can pick between is going to control how variable it ends up being in its behaviors. So it gives us a really sort of interesting setup of things. So it means stuff like turning on the TV and that can still happen. And because its fun is at a pretty high level, there's a penalty there for picking stuff from the bookshelf. Now, it's going to go and keep food from the microwave because the microwave is going to have a really high score at the moment. So it should tend to balance its bars pretty well because it's going to do things that line up with the general stuff that it's needing. Now, we've only added in a couple of stats there, but you could be adding in further stats. And so this is how a lot of the stuff works in The Sims. It's very simple on the AI side. The objects have a lot of logic in them. They have a lot of smarts with advertising these interactions. And with what we've set up, it's really easy to add in further ones, and we get behaviors that we don't specifically code for. And the thresholds we set for things like, okay, well, how large is that range of things it can pick from determines how much it prioritizes satisfying its own needs. An AI with a very large pick size is going to be a bit more chaotic in what it does. An AI that has a very small pick size is going to be very, very focused on what are my needs? I need to make sure my needs are satisfied first, and that's the priority. So you get a bit of a sense of just personality there, just from the size of that pick list is going to give a bit more of a different read and a different feel to the different characters. So it gives us a really good basis there for being able to create interesting characters. So it's something we'd dive on in and experiment, see the kinds of other things you could be adding to this in terms of setting up for different stats, setting up different interactions, setting up ones that are a bit more intricate. You could set up different curves for the different stats so they weigh differently. That scoring function is something that we would definitely iterate on a lot, and different characters might score things differently. Some characters might prioritize fun always, so that anything that adds to that might have a bonus, but anything that detracts might have a penalty. So you could set up different things like that with it. But dive on in and experiment with it and see the kinds of things that you can be doing. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you have any questions, chuck in a comment below. If you're looking for the code for the project, it is available up on GitHub. You can use that in any of your own projects, commercial, non-commercial ones. You're free to be using it there. And if you are looking for other ways to support the channel, I do have a Patreon, and there is a link to that in the description below as well. And there is now a video archive for all of the videos available up on the website, which I've got a link to that below as well. So that's something if you're wanting to search or track down the videos, that's going to be a bit of an easier way for finding them. And that link's in the description as well. But until next time, bye.